Hello students, welcome back. We discussed the standard error. Now let's talk about confidence interval. Find a 95% confidence interval. By the way, why did I erase it? Okay, the difference in percentage point. The expected difference, of course, is negative 5.8 percent points. So around negative 5.8 percent point, you're going to have a normal picture. Here we go. Remember the standard process: outline, center, end, and shade. Okay? Outline, we have a normal picture, and then center, you have to make appropriate decision. Center, what is the expected difference in percentage point? The problem says difference in percent points, and the problem explicitly said negative 5.8 percent points. So that's not difficult at all. Negative 0.058. The problem said negative 5.8 percent points, so change it to decimal. Okay, next, end. We want 95%, okay. 95% in the middle. So here's one end, x1, and here's another end, x2. And then 2.5% here, blue, and 2.5% there, red. Typical normal picture for confidence intervals. If you want not 95% but 90%, then similar kind of picture. In naked eye, you cannot make any distinction there. 90% here, 5% here, 5% there, kind of like that. All have to add up to 100%. So here, 95% here, 2.5% there, 2.5% there. Now that you got the picture, you'll have to find out the endpoints, right? x1 and x2. How do you do that? Here is formula number 1 that helps you. End minus center over SE. Let's make it a little bit bigger. And you need it for what? 95% confidence interval. So this z-score is gonna be negative. Remember anybody? Negative 1.96 for this guy. Positive 1.96 for that guy over there. Excuse me, let me stop this recording and let me bring back that normal table here in case there are some people who forgot. Okay, I brought the normal table here, and this part over here has to be 2.5%. Let's go back to this. This shading, 2.5% on the left-hand side endpoint. That's what we're looking for. So 2.5%, where is it? Right here. 0.0250, and that corresponds to negative 1.9, and then 6 columns, so negative 1.96. Consequently, you're going to get this. All right. What's the center here? We have it in this picture. What's the standard error? Oh, that was part A of this problem. Go back and check. And you have to check, you have to solve this equation to get end. Basically, that's the problem. That's going to give you this x1. And of course, by symmetry, you look for this one. All you have to change is minus to plus. So this will give you the left-hand side endpoint, which is in blue right now. And this will give you the right-hand side endpoint, highlighted in red. Okay, I'll stop here. As for finding out the n from this equation, same as the previous computations in one sample inference, so I'm not going to dwell in there. And of course, what's the point if I finish your homework problem here? So I'm not going to do that. I'll leave that to you. A brief recap on everything here. We have extremely realistic problem. Forget what I said about realistic. It's not realistic, it's real problem. We have a two sample inference. So okay, two sample inference, we have treatment and control groups. So we need two sample sizes. So sum is not that important, at least for the time being. We need group 1 for treatment, and we need group 2 for control. 99 and 100, N1 and N2. Color coding helps. If you use some highlighter, go ahead and use that. And if you don't, if you just use pencil, then circle for this and rectangle for that, do whatever texture. And then 19.2%, that's P1, and 25.0%, that's P2, because this comes from treatment, that comes from the control. The difference is the expected difference between the two, and just 5.8% points difference was not too big in this particular case. So if you do all those hypothesis testing later on, it'll turn out that the null hypothesis would win. Anyway, that's for a different problem. Okay, that's the setting. And how do you get the standard error? You should not forget this formula. The Pythagorean formula for standard error. SE is square root of SE1 squared plus SE2 squared. And how do you get SE1 and SE2? The previous standard error formulas for each group, group 1 and group 2. Square root of P1 minus P over N. I use color coding here. Remember, this is two sample inferences, so you need two computations, all right? And then in the end, if you have to do confidence interval, as usual, draw the picture. In the exam, I will require a picture, okay? If you don't draw the picture, I'm going to take some point off. Whether your answer is correct or not, I don't care. I'll take some point off. If your picture is correct and everything else is wrong, you're going to earn some credit. Okay, we have the picture. Outline, it doesn't have to be really perfect. And then center, straightforward, and the end, and then appropriate shading. I used 3 color shading here, but if you don't have 3 colors, in that case, keep the middle part as empty and then shade only left-hand side and right-hand side part. That's what I do if I use just pencil. Now, you can use the formula number 1, Z equals to N minus center over SE, or same goes for T formula as well. N minus center over SE. Center, negative 5.8% or negative 0.058. And SE is the computation you did in part A already. So you can complete this problem. Anything further, I'm not giving you. It's your problem.